Okay, so we are starting chapter 12. Chapter 12 is all about statistics and probability, so it's a little different than what we've been working on up until this point. So probability is how likely things are how likely things are to happen. So the lottery, flipping a coin, playing cards, those are all practicing games of probability. So first we're going to kind of define some of the main terms that we're going to use in this chapter. So there's a probability experiment, which is an action or trial with varying results. So a probability experiment is anything that could come up with different outcomes. For instance, rolling a die. Rolling a die is a probability experiment because you could have different outcomes. Those outcomes are the possible results of a probability experiment. I spell probability wrong a lot. Probability experiment. So where rolling the die is the probability experiment, those outcomes are 1, 2, 3, 4, 5, and 6. An event is a collection of more than one outcome. So instead of saying, what are the chances I roll a 1, an event could be the chances of rolling an odd number, because that would count for the 1s, the 3s, and the 5s. And then finally we have sample space, which is the set of all possible outcomes from a probability experiment. We represent that as S. So the absolute value of S is the size of the sample space, how many outcomes there are. So in this case, the experiment is rolling the die, the outcomes, 1, 2, 3, 4, 5, 6. That sample space, the size of it is 6 because there are 6 different outcomes. So this first example says, how many possible outcomes are there in the sample space of rolling a die and flipping a coin? So these are two different things are happening. So let's say, so you flip a coin. What are the two options there? I could get heads or I could get tails. And then when I roll the die, I could get heads and a 1, a 2, a 3, a 4, a 5, and a 6. Or I could get tails and a 1, 2, 3, 4, 5, and 6. So with all these possibilities, the sample space for this is actually 12 because there are 12 different outcomes. You get a heads in 4, you can get a tails in 1. So when you have two events happening like this, so when multiple actions take place, your sample space, or how big your sample space is equal to the number of outcomes of each event multiplied together. So in here, you flip a coin. How many outcomes are there? There's 2, heads or tails. And then when you roll a die, there's 6 outcomes. And so 2 times 6 is going to give you 12. So instead of drawing them all out like this, when they get more complicated, you can use that multiplication. So the way we represent the probability of an event. So the probability of event is always going to be between 0 and 1. If something has a probability of 0, it's impossible. For instance, if I roll a die, what's the probability I'll get heads? That doesn't make sense. The probability of that is 0, or 0%. Something between 1/2 and 0 and 1/2, something in this kind of area, we consider that unlikely to happen. So something that has a 25% chance or a 0.25. If something has a 50% chance, that means it is equally likely and unlikely. So it could happen, it could not. That doesn't sway one way or the other. More than that, you would consider that likely. And then sometimes something is the probability of a 1, and we call that a certain event. So it's something that has 100% probability. So if I was to roll a die, what are the chances I'd get a number between 1 and 6? That's 100%. That's a certain event. So, however, it isn't always exactly how that works out. There's theoretical probability and experimental probability. So theoretical probability, you get the fraction, which is number of favorable outcomes. We say favorable as in what we are looking for in this case. Number of favorable outcomes over the number of total possible outcomes. So if I was to roll a die, let's say I want to roll a 3. Well, only one of those options is 3, so a 1 would go on top. Out of 6 possibles, 1/6. Now, an experimental probability would be the number of favorable outcomes in an experiment over the total number of trials. So let's say I know that there's a 1/6 chance I'll roll a 1. But let's say, so with rolling a dice, theoretical probability of rolling a 1 should be 1/6. However, the experimental probability, maybe I roll a 2, a 1, a 6, a 5, and a 1 again. Now in this case, I had 6 trials, and 2 of them came out as what I wanted. So the experimental probability is actually 1/3. So your theoretical probability and your experimental probability don't always work out. The theoretical probability is just an idea of what should happen. All right, so now please go and watch 12.1 part 2.